Salam sejahtera, my name is Damien Sigau and my magic number is 97341. In this video, we will be presenting our project for KNP2013 manufacturing technology. For this project, we focus on the design and production process of food products. Throughout the presentation, we will walk you through the concepts development, system design, production, workflow, and the key outcomes of our work. We hope that this presentation provides a clear understanding of our project and highlights its relevance in the context of modern manufacturing practices. Without further ado, let's begin with our introduction. In this modern era, there is a growing appreciation for incorporating Malaysia's traditional ingredients into a contemporary food products. These ingredients not only preserve our rich cultural heritage, but also promote local agriculture and support rural economies. One such ingredient, widely recognized and cherished in Sarawak, Malaysia, is gula apong, which is a traditional palm sugar that has been used for generations. So, in this project, our team aims to develop innovative food products using traditional gula apong as the main ingredient, paired with efficient modern manufacturing processes. This approach not only supports local industries and appeals to health-conscious consumers, but also aligns with several United Nations Sustainable Development Goals. For example, SDG 3, which is about good health and well-being, and then SDG 8, decent work and economic growth, and lastly SDG 12, which is responsible consumption and production. By using gula apong, we highlight the richness of Malaysian heritage while creating opportunities for small farmers, entrepreneurs, and manufacturers to innovate and compete in modern markets. Next, the objectives for this project is we aim to develop gula apong flavored food product. Next, to design an efficient production line for the mass production of gula apong products. Then to optimize the production process to ensure cost effectiveness and sustainability in the production process. Last but not least, to contribute to sustainable development goals. So, to better understand our direction, let's briefly explore the literature review that supports our project.
Today, I will explain the production of gula apong and how it connects to our apong cookies project. Gula apong is made by collecting sweet sap from nipa palm tree, then boiling it for hours to get a thick golden syrup. It is a traditional product of Sarawak, known for its natural sweetness. We use various sources like videos, articles, books to understand this process and apply it to cookies making. Apong cookies are made through 5 main stages, which is mixing ingredient, shaping, dough, baking, cooling, and finally packaging. There are 2 main production methods, which is a small-scale manual tools and a large-scale automated line. So, for our project, we are choosing large-scale automation because it can produce 150 to 500 biscuits per minute, which it ensure consistency, save time, and reduce labor and cost. We also choose this method because we want to produce a lot of cookies for our company.
Next, let us discuss about the findings of our chosen product, which is the gula apong biscuit. This innovative biscuit features gula apong, which is a natural sweetener extracted from the sap of a nipah palm tree, which are commonly found in Sarawak. So why do you use gula apong instead of white sugar? Is because gula apong has a lower glycemic index or GI than that of your typical white sugar, and by incorporating this local ingredient into our product, we aim to promote the traditional food heritage while also offering healthier and a more marketable product. So let's talk about raw materials. So as the raw materials are readily available, we can reduce the production cost of our product. These raw materials include gula apong, eggs, butter, and flour. The cost of our production is also affected by bulk purchasing. So when we talk about food product, we must also relate it to the shelf life. The typical shelf life of biscuit is around 6 to 12 months from the manufacturing date. So the preservative that we hope to use in our product is the organic one, which is tocopherol, which is contain mainly of vitamin E. So in this context, vitamin E is not just used to prolong the shelf life of our gula apong biscuit, but also to help keep the taste fresh. Next, we have the manufacturing process of gula apong biscuit. Mainly, we have 5 processes. Starting with the preparation of ingredients, we prepare raw materials like flour, butter, eggs, and gula apong, and it is measured and then prepared accordingly. The gula apong is gently melted and filtered to ensure smooth texture and consistency when it is later mixed with the other ingredients. Each unit of ingredients is sufficient to form one dough. So then the second process is the mixing process. The raw ingredients are combined in industrial mixers to form dough. The dough is then let to rest for some time for the gluten to relax, which is to ensure further even distribution of the gula apong across the dough. And for the third process, we have the shaping process. The dough is shaped by an automated shaping machine onto a tray in a certain neat arrangement. The arrangement is so that the cookies can expand uniformly when it is later baked by an oven. The cookie size is about 5 cm in diameter and 1 cm in height. And moving on, we have the baking. The trays containing the gula apong biscuits dough are transferred on a conveyor belt where they are baked along the process at controlled temperatures at between 200 degrees Celsius to 220 degrees Celsius for optimal taste and texture. The baking process takes approximately 4.5 minutes, just enough time so that the cookies turn brown and not burn. And lastly, we have the packaging process. After the cookies are baked, it is then let cool on the tray before being packed using an automated packaging machine, labeled and sealed to ensure better shelf life.
So my name is Carldrige Ganing, and Luget, and I'm going to present for the product design for our project for AutoCAD software using AutoCAD software. So based on the pictures, this is the sketching model for our AutoCAD before doing AutoCAD. We have ingredient collector, mixer, shaper, baker, packaging machine, packaging style, and our product, which is apong cookies. So this is our design using the AutoCAD software before 3D printing it. So the first pictures, there's a pipe part for the mixer machine. So then we have the machine part for ingredient collector and mixer. The third one is a packaging machine part. The fourth one is the baker part. The fifth one is shaper parts, and the final one is our product part. Okay, after that, this is our during the process 3D printing for our model. So this is our final product after the 3D printing process. So the left one is for the machine parts and the right one is the feature for the product parts.
For my role in this project, I was responsible for designing the production line using Arena simulation software. So I developed a layout specifically for the production of gula apong cookies. Now let me show you the simulation run of the production line in Arena software. Based on the simulation results, the production line is capable of producing 1008 cookie packages per hour, which is successfully meets our daily mass production target. This demonstrates that the system is both efficient and capable of handling large-scale output.
Hi, my name is Ainin Sofiya Binti Romzi with a matrix number of 97230. Now, let's get through the manufacturing production cost for our apong cookies. For one unit, which includes 12 cookies, we estimated the total production cost to be around 5 ringgit 62 cents. Most of that comes from the ingredients, which cost around 4 ringgit 92 cents per unit. Since the production is fully automated, the electricity cost that is used by the machines is about 50 cents per unit. We also included 30 cents for the packaging and another 25 cents to cover other expenses such as machine maintenance, cleaning and water. Therefore, at the end, it costs only 5 ringgit 62 cents to produce each unit. Next, let's look at our total profit estimation. We have set our selling price at 10 ringgit, which gives us a profit around 4 ringgit 38 cents per unit. With a daily production target of 10,000 units, that means our total daily profit will be 43,790 ringgit. That's a 43.8% of profit margin, which is strong, especially for a product that is affordable for mass market. This shows our business model is both cost efficient and profitable while still offering a good value to customers. To conclude, the apong cookie project shows how traditional ingredients like gula apong can be innovatively used in modern food production. It supports local agriculture, preserves cultural heritage, and promotes healthier food options. Our production line that was designed by AutoCAD and Arena is fully automated and capable of producing about 1,008 packs per hour, ensuring consistency, hygiene, and cost efficiency. By using advanced equipment like machines and conveyor ovens, we have increased the production capacity while reducing manual labor. Furthermore, we have lowered the production cost to 5 ringgit 62 cents while maintaining the selling price of 10 ringgit. This gives us a healthy profit margin of 43.8%. Overall, this project is not only economically viable, but also support the Sustainable Development Goals and encourage rural economic development through food innovation.